everyone, and welcome back to another episode. I am so glad you guys are sticking with this whole math thing. Who knew you were going to love math? I did. So anyway, we're actually going to do something a little more challenging, just a tad. So let me share my screen with you guys. So today we're going to work on factors, divisibility test, and prime factorization. So we're looking at the Common Core Standards A, SSE.1, A meaning algebra. And we're going to work on those algebra skills. And it's almost like I'm showing you a short way of how you can factor, okay? Especially when we're dealing with really large numbers, as anything in the thousands. So let's first look at our exit ticket from last time. So if you recall, last time we were looking at the different notifications, the domain and the ranges to see if it's a function or if it's a relation. So remember, when I look at my set, I'm looking at the set of T. And within that set, I have a couple ordered pairs. And all these ordered pairs is making this set into a relation. So I have 1, 2, 4, -3, 5, 7, and 3, -3. So we want to answer the following questions. First thing, we need to list the domain of T. So remember, if we're going to list the domain, that means we need to keep it in a set. So the set of my x's. And all we're doing is listing all my x values. So we have 1, 4, 5, and 3. But since we kind of like to put this in numerical order, so let's do that 1, 3, 4, and 5. So that's going to be my domain. So we'll just zoom that out and we're going to focus on that one. So now my range is going to be the set of my y values. So if I go my set of my y values, if I start from lowest to highest, my lowest is -3, then it's 2, then it's 7. And hopefully you're saying, well, Miss Conner Gibson, hello, girl, you forgot a -3. Remember, you don't have to write it down twice. You just have to write it down once. All right. So now it's asking, is T a function? So how can we tell if it's a function? It's a function if you have one x going with one y and they have that relation. Okay. 1 to 1. Let's keep it good. All right. So I can look at my domain. Did any of my domain repeat? And my domain did not repeat. I had a 1, a 4, a 5, and a 3, and it went for all 4 of my x's that's in my relations. So basically, yes, this is a function because my x's did not repeat. Ooh. Look at this handwriting. Isn't it beautiful, guys? Sarcasm. Okay, so that's what we worked on last time. But this time, our learning target and our agenda is I can identify factors of whole numbers using divisibility tests and simple, supposed to say simple, and simply numbers using prime factorization. So we're looking at the agenda. So we already did the exit ticket. Now we're going to work on our notes and our practice. So first off, I'm kind of in the way. Let me see if I can move myself out the way. There we go. So whole numbers that we multiply are called factors of their product. So if we think about the word product, product is dealing with multiplication. And the numbers that you're using to multiply, those are your factors, okay? So the type of numbers that you use are also prime numbers and composite numbers. And we talked about prime and composite before when we did the whole square root thing, okay? When we were breaking down the square roots. So remember, those prime numbers are any whole numbers greater than 1 whose factors is 1 in itself. So my first prime number, if we recall, is a 2, because the only way through multiplication that I can get a 2 is 1 times 2. Now, composite numbers, any whole numbers greater than 1 that is not prime. So an example of a composite number would be 6, because what can give me 6 through multiplication? 1 times 6? 3 times 2, and the reverse of 3 times 2, which is 2 times 3, and the same as reverse of 1 and 6, okay? So I have more than one set of factors that can give me this answer of 6 through multiplication. So now when we talk about the prime factors, It's basically the numbers, okay? A prime number that divides evenly into a whole number with no remainders. So if I have a prime number, 3. So if I said 18 divided by 3, that would give me 6. So that means 3 and 6 are going to be like those prime factors, okay? And you're thinking, well, 6, didn't you say that 6 can break down to 3 and to 2? But what type of numbers are 3 and 2? Prime numbers. So there's always some special situations that can come about to help us break down these factors, okay? So now this is when it gets fun and funky. So sometimes, especially on the SATs, ACTs, college entry, any kind of college entry exam or anything, they always say, well, are these numbers divisible by 2? Is this number divisible by 8? And you're looking at this number that's like 3,464, 2,000, oh yeah, so much. And you're like, I don't know, like, how do I figure this out? And then you're sitting there with your calculator, like freaking out. Ah! Stop, breathe, relax. Let me show you how to do this, okay? So when we're looking at factors, we're looking at 2, 3, 4, 5, 6, 8, 9, and 10, okay? Most of those even except for 5 and 9, right? Now, 2 we can kind of understand. So take a look. So 2 is a factor of a whole number that ends in 0, 2, 4, 6, or 8. Okay? So if you're looking at a large number, look at that last digit. Look at that 1 spot. Okay? And if it ends in a 0, a 2, a 4, a 6, or an 8, that means it's divisible by 2. Okay? So for the next one, 3 is a factor of a whole number if the sum of its digits is divisible by 3. Let me tell you what I'm talking about. So if I have 4,251, right? And they're saying the sum of the digits. So that means I'm going to add 4 plus 2 plus 5 plus 1. Okay, 4 plus 2 gives me 6. 6 and 5 gives me 11. And 11 plus 1 gives me 12. Now, thinking of our multiplication, is 12. Can 12 be divided by 3 without a remainder? Yes, it can. Because if I divide this 12 by 3, I'm going to get an answer of 4. Okay? So since that's possible, that means this number of 4,251 is divisible by 3. What? Did that make it a little easier for you, babies? Please, let me help you. All right. So 4, now we're going to take out 4. So 4 is a factor of any number if the last 2 digits are divisible by 4. So if I do, let's say 3,432, okay? So we're not looking at the whole entire number. We're going to look at the last 2 digits, the 32. Is 32 divisible by 4? AKA, can I take 32 and divide it by 4 to get a whole number for an answer? Yes, I can. And hopefully, you guys are saying 8. So if it is possible, that means this number is divisible by 4. Okay? And taking a look at this number, I'm looking at right here, and just looking at the last digit, this number can also be divisible by 2 because it ends in 2. See how I'm carrying it over? Okay? So 5s are pretty easy. If the number ends in a 0 or a 5, it's divisible by 5. Okay? Now 6, this is when it gets a little hairy. So in order for it to be divisible by 6, it has to be a number that can go with the same properties of the 2s and the 3s. So let me see, take a couple of my notes. Let's say if I want to say 474, okay? Let's keep it simple for right now. So you're saying, all right, it ends in 4, so right away, it's going to be divisible by 2. That's wonderful. Now let's see if it's a factor of 3. In order for it to be divisible by 3, I need to add these numbers and to see if it's going to give me an answer that can be divisible by 3. Last time I checked, 4 plus 7, that gives me 11. 11 plus 4 gives me 15. And 15 can be divided by 3 without a remainder, which is 5. So that means this number of 474 is divisible by 2 as well as 3, okay? So if it works for both 2 and 3, that means it can be divisible by 6, all right? So if I tried to divide that 474 by 6, let me put my division by 6. Last time I checked, I think that's a 79. So that will give me an answer of 79 without a remainder. So that means 474, the best bet will make it divisible by 6. So now for 8 is a factor of a whole number if the last 3 digits is divisible by 8. So when you're looking at 4, you're looking at the last 2 digits. When you're looking at 8, you're looking at the last 3 digits. So let me give you 4,000. Yep, we're back to the thousands again. 320. So I'm looking at the last 3 digits. So I'm looking at that 320. Now, can 320 be divisible by 8 without a remainder? Yes. Hopefully, you guys were saying it'll give me an answer of 40. So since the last 3 digits is divisible by 8, that means this number 4,320 can be divisible by 8. But what else could it be divisible by? It could be divisible by 2 because it ends with 0. It could be divisible by 4 because if I look at the last 2 digits, okay, 20 divided by 4 gives me 5, so that's divisible by that. And it also could be divisible by 5 because it also ends in a 0. All this knowledge. Hopefully you guys are feeling better because usually people feel like, what? How can I find it? So now we're looking at 9. So 9 and 3 are very similar. Just like how 4 and 8 has a little similarity, but 9 and 3 are very similar. So if I use the same number, 4,251, okay? We did this earlier. And we said when we did through math, through problem 3, if we add 4 plus 2 plus 5 plus 1, that gave me an answer of 12. Now, that works because 12 is divisible by 3. But will it work? Will the 12 work for the 9? It won't work for the 9. So that means this number is not divisible by 9 at all. But let me give you something that is. Let me erase this. So if I give you 3,456, if I add up my digits, so 3 plus 4 plus 5 plus 6, I notice my 4 and my 6, I got 10, and my 5 and the 3, that gives me 8, so this gives me 18. Remember, I can do grouping, don't forget. So now, is 18 divisible by 9? Yes, because 18 divided by 9, that will give me 2. So that means this number, 3,456, is divisible by 9, all right? So you see how it kind of goes? And then 10s, we all know 10s. If it ends in 0, it's going to be divisible by 10. So hopefully you're seeing that when you see one number, it doesn't have to be just divisible by one factor. It could be divisible by multiple factors, or it could be divisible by nothing at all because it could be prime, all right? So speaking of prime, we're going to look at prime factorization. So it's probably back in the day when your teacher talked about prime factor trees, when you had this, which I'll show you in a few. So it means you're going to write a number as a product of this prime factor. So the very end, all your factors are going to be prime numbers, okay? And we can definitely use division to break that down. So let's take a couple examples. So we have 23,340. And we want to see if it's divisible by 2, 3, 4, 5, 6, 8, 9, and 10, okay? So first, we need to find the sum of our numbers, and that's going to help us with which one. If I add them all up, it's going to help me with 3, and it's going to help me with 9. But just looking at the last digit, right away, I know it's divisible by, I know it's divisible by 2, I know it's divisible by 5, and I know it's divisible by 10. Why? Because my last digit is 0. All right? So if I add them up, if I go 2 plus 3 plus 3 plus 4 plus 0, okay? We know that 0 is basically a placeholder right now. So 2 plus 3 gives me 5. 5 plus 3, or 5 plus 7, will give me my 12. Now, is 12 divisible by 3? Yes, it is. So I can do 3. But is 12 divisible by 9? No, it's not. So right away, we can cancel things out. You see how just by adding, I was able to eliminate 2 options or find something out of 2 options, okay? Then I'm looking at 4. So remember, the 4s, I'm going to look at my last 2 digits, which is 40. So is 40 divisible by 4? Yes, it is, because it gives me 10. Boom, that works. So if I want to do 6, remember, in order for it to be divisible by 6, it has to appease the whole properties of divisibility of 2 and divisibility of 3. When I look at 2 and I look at 3, and it both checked out, guess what? 6 is on the board too, all right? So now I'm looking at 8. So remember, 8's kind of similar to 4, but instead of looking at the last 2 digits, it's looking at the last 3 digits. So now we got 340. So does 340 appease it? And hopefully you're saying yes, because 340 divided by my 8 does work out. So it seems like the only one doesn't work out in this case is 9. So it's going to be 2 is divisible by 2, 3, 4, 5, 6, 8, and 10. All right? So it works for all of those except for 9. Let's try the next one. So now we have 8,244, and we want to see if it's divisible by the same numbers that we did last time. So looking at the last digit, it's 4. So that means 2 works out. What else works out? 4 works out, because 44 divided by 4 gives me 11. So that works out. What else does it work out? Does it work out 3? Does it work out 5? Because it doesn't end in 0 or 5. So we can cancel out 5, and we can also cancel out 10. All right? So now let's see if it works for 3. So we have 8 plus 2 plus 4. So 8 and 2 is 10. 4 and 4 is 8. 10 and 8 is 18. And is 18 possibly divisible by 3? Yes, it is. It'll give me a 6. So it works for that. So since it works for 2 and 3, that means it also has to work for 6. And since we got an answer of 18 when we add it, it's also divisible by 9, because 18 divided by 9 gives me 2. So now the only thing that we have to do is check out 8, and that means I'm looking at the last 3 digits. So 244 divided by 8, I think that's going to give me a decimal, guys. And I'm right, it gives me 30.5. So that means I'm going to have that remainder. So 8 does not work. So I think the only ones that don't work is 5, 8, and 10. So that means my answer for this is going to be 2, 3, 4, 6, and 9. Okay, hopefully you guys are getting this. All right, so now we're going to talk about prime factorization, the factor trees. So what it is just writing your numbers as product in your prime factors. So when I look at 36, I want to know what 2 numbers multiplied together will give me my 36. So there's multiple ways. You can do 4 times 9, you can do 6 times 6, But no matter what happens, even if you do the same old 1 times 36, please don't, not right now, okay? You want to break it down to the point where all your digits, all your finer factors are going to be prime numbers, okay? So that means when I multiply these 4 numbers, 2 times 3 times 2 times 3, it will give me my original product of 36, okay? So that's all we're basically doing. We're breaking it down because there's a method to my madness, because we're going to get into something a little bit later on where this prime factorization is really going to help you out. Even when we were breaking down the square roots, that really helped you out, okay? So I can do 140, I can break it down to 14 and 10. So breaking down the 14, I can get my 2 and 7. And breaking down the 10, I got my 5 and 2. And if I want to rewrite it in numerical order from lowest to highest, I could. I could say 2 times 2 times 5 times 7. And 2 times 2 gives me 4. 4 times 5 gives me 20. And 20 times 7 gives me my 140. Okay? All right? So the same thing can happen with your 420. You can split up the 42 and 10, okay? Because this is all multiplication. So I can break down that 42 to 6 and 7. And I can break down my 10 to 5 and 2. And then 6, I can break down once more to 3 and 2. So now if I put it in order, I got 2 times 2. Okay, so that gets rid of that 2 and this 2. Times 3, got rid of that one. Times 5, times 7. And this will be my prime factorization. All right, so going back, I can identify factors of whole numbers using the divisibility test. Hopefully you can, because we definitely went with it. We went the 2, the 3, the 4, the 5, the 6, the 8, the 9, and the 10. Okay, and then we also figured out how to simplify, that's what it's supposed to be, numbers using that prime factorization, aka your factor tree. So I can check that bad boy right off. We definitely reviewed the exit ticket. We looked at notes and practices. We did little exams. So now we're going to do that exit ticket. So here's your exit ticket. So I basically want you to test for divisibility, okay, by 2, 3, 4, 5, 6, 8, 9, and 10 for that number 3,420, all right? And then find the prime factorization for the following whole numbers, which is 112, all right? So as usual, this has been a joy and a pleasure for me to do these videos for you. I've been getting a lot of great feedback, which is awesome. Some through my email and some through YouTube. So if anything, keep pushing, keep working. And if you need any assistance, please do not hesitate to go to acgmathtutoring.com and we can see if we can set up a tutoring session. Or even if it's just a quick question, go ahead and email me, acgmathtutoring@gmail.com. So hopefully everything's going all right, and I will see you next time. Bye.